Okay, so today we are expanding logarithms. So with expanding logarithms, there's something that you need to know. You may not know what that means. So what you have to remember that a log is an exponent. Remember when we did the whole log switch, you had log base something with some sort of value here is equal to that exponent. This log is an exponent. So any rule we had with exponents, all exponent rules are now log rules. And logs do rule, so that's good to know. Okay, so just remember, we went through this already, but if it has no number written on it, it's base 10. If it has, well, if it's an ln, it's base e. You may have forgotten fractional exponents are radicals, so if you have a radical, we are going to have to write them as exponents. Okay, so we have to be able to do this from this today. All right, so just as a reminder of what our exponent rules are, we're going to translate them to log rules. So the product rule, when you multiply two exponents, you add, when you multiply bases, you add the exponents. So when we multiply these values, we're going to add the exponents. So the exponents are the two things. So log base b of a and log base b of c. Notice we're adding them together because we multiplied them. So ln of a plus ln of c. That's expanded version. So each variable gets its own log. So when we're expanding, excuse me, I write weird, each variable gets its own log. There should be no, that shouldn't be there. Gets its own log. Okay, so when we divide values, we subtract. That's a b. We subtract exponents. So we subtract logs. So when we divide, we subtract logs. It's always the top minus the bottom. Okay, so it's the log base b of a minus log base b of c. Okay, so the log of the top minus the log of the bottom. I don't know why there's so many ln's here. And then, interesting, when we do a power to a power, we multiply. So remember, power to a power, we multiply exponents. So that's what we're going to do. This exponent gets multiplied, and you can times the log. So it's c log base b of a. So it's, Mrs. Zamfini likes to say, drop it like it's hot. So this c comes out in front, ln of a. So those are the three rules. If you multiply, you're adding. If you're dividing, you subtract. And if you have an exponent, it comes out in front. Okay, that's it. Those are the three. Just like in exponents, there's only three. And remember, each variable will have its own exponent. So I like to do this a little shorthanded way. So each variable here is going to have its own log. Now, since these two are multiplied together, we're going to put a plus sign. Okay, same here. These two are divided. There's two variables. So I'm going to have two logs. The two are divided, so I subtract them. Notice this symbol and this symbol are the same. Maybe that'll help you remembering that you have this line here, you're going to be subtracting. Now this one is an exponent on top, so then it comes out in front. And that's going to be our most useful tool. All right, we have two variables. We have the ln of a squared, and we have the ln of c. So, and these two are added together. The only thing we have is we can't have exponents either, so this exponent has to go out in front. I realize it seems a little weird, but we're going to use this a lot when we're solving equations. So you have to learn this process so that you can solve log equations a little bit better. So we expand, and then tomorrow we condense, and then it's a whole lot of love and fun. Okay, this one doesn't have an exponent right here, but what we can do is write it as an exponent. It's a radical, so remember, when there's no number there, it's a 2, so it would be b to the 1/2, and this 1/2 comes out in front. Okay, so this is my thing. First thing I like to do is rewrite it with fractional exponents. 1/2 over b. Now there's two variables, so I'm going to have two logs, two ln's. So this line right here is division, so I'm going to subtract. Okay, and that a has a 1/2 exponent. So that 1/2 comes out front. The only way to get better at this is to do it constantly. Okay, to do it a bunch. So, all right, so there's a few here. Try a couple of these. See if you can do these, and then we'll come back and show you what I got. Okay, I'll just go over these one at a time. So this first one, it's got two variables, and these are pretty straightforward, simple questions. So we are going to have two logs. It's division, so we subtract, and this 1/2 power goes on the front of just x. Okay, with this particular one, there's two possible ways you can write this. You can write it like this or like this. Notice this 1/2 power is on both the x and the y, so you can drop it like it's hot first, but just you have to put these parentheses to show that they're, you can distribute that in, or that the 1/2 goes to the x and the y. The alternative is to take that 1/2 and put it on the x and the y first, and then put the 1/2 in front. Both of these answers are acceptable, but you should know, looking at multiple choice and things like that, that these are both correct. Okay, try the next one. Okay, with this one, these are added together. These are multiplied together, so we're going to add their logs. The b is the only one that has the 1/2 power, so the b gets the 1/2. Right, this one is a lot like number 8 up right above. You could deal with the exponent right away and bring it out in front first. Just you have to put the parentheses here. Or you can go right to this, distribute that 3 in. It would be log base 5, a to the 6th, b to the 3rd, and you go right down to this one. So this answer here and this answer here are fantastic. Both of them are acceptable and both of them are great, whichever way you like to see better. So important facts about the ln and log, about anything. Log base b of b is always 1. So when the base and value match, the answer is 1. And as you can, if I can show you, if I have log base b of b, and I don't know what that is, remember I can do the log switch. It's b to the x equals b. Remember the log switch? And that would be that x equals 1. So that's where that comes from, so that you're aware. You do the log switcheroo, or whatever you want to call it. Oh, hey, that was fun. So you do the log switch, and that works. So same deal here. We can figure this one out. What is that? Well, let's do base. We don't know what this is right now. So base to the x power equals 1. Well, what's anything? What power does x have to be for anything to be 1? Well, x has to be 0. Correct? Anything to the 0 power is 1. So that lets us know that that's a 0. So if whenever, excuse me, oops, I got this. Whenever you have a 1 right here, that's 0. So the ln of 1 is 0, because I just said anytime there's a 1 there. And the ln of e is the same as log base e of e. So these two now match, so that's 1. Anytime these two match, the answer is 1. And that's all good. So we can play with a couple of these. Things get fun when we start doing this. So we expand these. If I expand this as log of 10 plus log of x. So remember, this, when it's just plain old log, it's log base 10 of 10 equals the log of x. So anytime these match, that's 1. So this answer is actually 1 plus the log of x. Blows your mind, doesn't it? Blows your mind. So try these, and then I'll explain them in a sec. Okay, this one here, you have division, so we subtract. And then this has a power e, had this squared here, so I brought it down in front. Remember, ln is the same as log base e of e, and anytime these two match, that's 1. So it's 2 times 1, which is 2. And then this is just the ln of 4. This one over here, we'll just bang these out here. This is log base 4. This has a squared. And then they're multiplying, so we add. And the x's just gets a variable by itself. Log base 4, these match, so that's 1. So it's 2 times 1 plus the log base 4 of x. So it's 2 plus the log base 4 of x. These take practice if you don't quite see it. The 3 things you just have to remember is you've got a division, so we subtract. Okay, the power goes out in front. And then you can evaluate if you can. The ln of 1 is 0, and the ln of e is 1. So this is 0 minus 4, so that's negative 4. So this is actually the value, negative 4. Plug it in your calculator and see. All right, have a great day.